Yep, good day, good day. I'm thinking about making a new video about the induction coil and capacitors. Now that the secondary is coiled a couple of times anew, I also made some new capacitors. These ones, salt water capacitors, with an iron rod in the middle. Salt water and aluminum foils insulated with some transformer resin. Then there is also the spark gap. This guy, there's a minute distance over the gap. And we're gonna see that the spark gap is slightly gonna be increased as the intensity of the capacitors are added on. Then there's the supply. There is 230 volts AC going through the 5 amperes fuses. Then there is the primary, this guy. It's about 1000 turns of a wire, about 24 gauge, 0.5 millimeters diameter. This guy is about 23,000 turns, and the ratio is about 1 to 23. Perhaps. The voltage is about 1000. It should have been a lot more, but there is some losses that I've not managed to deal with. Then there's the steel plate capacitor. It looks a little bit like this. It's 12 plates of bare steel plating that is attached vertically to this chassis, and its distance is about 2 millimeters or something. It's not exactly a straight line, but it's as good as I could do it. Then there's also the light candle test. Gotta see how the discharge or electrostatic behaves over a flame. It's kind of interesting. Now I'm going to fire it up and see how it works. Now I've attached the electrodes to some of these pins. So this one of the capacitor electrodes goes to this guy, and the other goes to this guy. I'm going to first attach I can try this one first. This guy first. So first I'm going to fire it up without nothing. Then there is this. It's not too much going on. It's a little bit moody too, but if I then, it's maybe a millimeter, and if I then attach a steel plate cap, you can see there's something going on. So this is a steel cap when it's on. So maybe it can be increased a little bit. It should have been more effect, in my opinion. But it's not jumping that far. You can see it's making some erratic jumps, but it's not that conclusive. However, now I'm gonna remove this, and then I'm gonna attach the salt water cap and test that one. That's the first electrode. This is the second guy. Nothing. That's Wait a second. This is the, yeah, I'll take this one off and this one on. Yeah. Why? Okay. Now, this is with nothing, and this is the salt water. So it's about the same. It's hard to tell. But when I wire them together, that's when it starts to get interesting. Now I'm gonna have to do something. Yeah. Well, first I'm going to attach this one. Then I'm going to attach the salt water in this one. Like that. Then I'm going to attach this. Okay, now I have to take them a little bit apart and it's more visible. I can see it's a little bit better, but now I'm så. So as the electrodes heat up, the spark gap grows longer. So it's when the electrode is pretty hot, the spark gap is increased up to maybe 5 millimeters or something. So then I can see. Now I'm going to. This is just salt water cap. In fact, now comes both of them. So if I have. Now I'm having both of them. So now I'm adding the steel cap. Så. So it gets pretty hot. The difference between the salt water cap and the steel cap is that the salt water cap heats up the electrodes intensely. And that's it for that. Now I'm gonna test the candlelight, the wind. It's an electrostatic wind that seems to be forming over the flame. So now I'm gonna fire this one up and see if we can get yeah. I'm gonna take the small one because the small electrode heats up faster. Burns better. It's a little bit too distant. And it's maybe a little bit too carbonized too, but it's gonna come sometime. There it comes. Now let's see the flame. The flame is in. First of all, it's visible that the flame, that the spark gap is much longer. The discharge length is about 1 centimeter maybe. And it's possible to see. Yeah, well, it's the arc seems to form a bow toward the flame, and the flame seems to stretch towards the electrodes. If both electrodes are on one side of the wick, then it blows it out. There comes this wind out of the discharge. It's kind of interesting. Just gonna make a little, maybe it's possible to see. If there you can see it. So there's clearly something there. Okay, so it interacts with the flame, that's for sure. What exactly happens is it's up for studies. Now what I'm thinking about doing is to make a larger secondary, so we get a higher voltage, and then to see where the capacitors eventually break down. This steel capacitor is sometimes arcing over between the plates, meaning that the distance between the plates is a little bit too small. So the distance must be increased, and or the change of dielectric. So I have to use some kind of material, some other material instead of air. I'll look more into that. And the procedure will be like to build a capacitor or build a coil, and then to see where it breaks down, and then to repair it, and then improve it. That's the case. So that's that. Good evening. Laters.